An enigmatic planet has captured the attention of both scientists and space enthusiasts. The James Webb Telescope has just revealed the clearest image ever seen of the surface of Proxima B. What mysteries does this distant world hide? Is it possible that it harbors life? If we delve into the history of the universe from billions of years ago, we can observe how galaxies emerged. With the James Webb Space Telescope, we can take this research to a higher level, exploring the most remote regions of the cosmos. The infrared images captured by the James Webb are unlike anything the human eye has ever seen. Its ability to observe the universe depends in part on how it is used. Similar to filters on a mobile phone, the James Webb Space Telescope allows astronomers to study the earliest moments of the universe and better understand the birth of galaxies, stars, and planets. Scientists can analyze the hues of these images using its camera and filters to capture a specific range of light colors. Additionally, this telescope will investigate the atmospheres of planets outside our solar system, searching for signs of extraterrestrial life. Recently, the James Webb Telescope captured the most detailed image of Proxima B's surface ever recorded. In 2013, astronomers noticed a small gravitational tug that a planet exerted on its star. After years of searching, this planet orbiting Proxima Centauri was named Proxima B. The fascinating aspect of this discovery is that it's the closest stellar system to Earth after the Sun. Observing the Alpha Centauri system, located approximately 4 light-years away, is like looking into the past, as we see it as it was 4 years ago. Proxima B stands out among the most spectacular astronomical discoveries, as it's only 4 light-years from Earth, making it one of the closest exoplanets to us. Despite its proximity, Proxima B is very different from our planet. It has 30% more mass than Earth, which implies that it's also larger. But its year lasts only 11.2 Earth days, because it orbits at a distance of just 7.3 million kilometers from its star. Although it may seem extremely close and should be a scorching world, Proxima Centauri is a red dwarf that emits much less heat than our Sun. What would it be like to stand on the surface of Proxima B and observe Proxima Centauri? The star would appear as a reddish disk approximately 3 times larger than our Sun in the sky. If the planet is in the habitable zone of its star as suspected, there could be favorable conditions for the existence of liquid water. However, before dreaming of an interplanetary adventure, it's important to know that Proxima B is far from being a second Earth. For example, it's highly likely that the planet is tidally locked, meaning that one side always faces the star, while the other remains in perpetual darkness. This creates an extreme environment that's inhospitable to life as we know it. Moreover, any water on the side facing the star would quickly evaporate due to its intense radiation. Conversely, on the dark side, the lack of heat would cause water to freeze completely. Although Proxima Centauri is much smaller than the Sun, its compact size causes the nuclear reactions in its core to be closer to the surface, generating turbulent activity. This chaos produces strong magnetic fields that emit high-energy radiation and particle bursts, which poses a challenge for any planet like Proxima B, orbiting in the star's habitable zone. While astronomers had some data on the magnetic fields of nearby stars, until now, precise details about Proxima Centauri's conditions were unknown. A recent study using magnetic field resolution maps has allowed for a better understanding of Proxima Centauri's solar wind and the difficult situation in which Proxima B finds itself. According to the study, the planet receives about 2,000 times more solar wind radiation than Earth, which poses serious difficulties for the possibility of life on its surface. In April 2021, Proxima Centauri emitted a flare 100 times more powerful than any recorded on the Sun, making it difficult to imagine that life could withstand such radiation without specialized protection. Although the idea of a habitable planet around Proxima Centauri is attractive, the reality is far from favorable for life. Humans have always been fascinated by the possibility of finding extraterrestrial life. In late 2020, this fascination grew when an unusual signal was detected coming from the Alpha Centauri system. The signal, captured at a frequency of 982.07 MHz, does not match typical signals from satellites or Earth spacecraft. While some experts suggest it could be interference from a man-made device, others maintain hope that it's evidence of intelligent life. The idea of traveling to Proxima Centauri, the closest stellar system to us, and finding extraterrestrial life might not be so far-fetched. The Breakthrough Starshot initiatives are investigating how to reduce travel time from hundreds of years to just decades. Recent research explores how current technology could overcome the challenge of accelerating an object, especially when approaching the speed of light. Even so, with current technology, it would take about 6,000 years to reach Alpha Centauri, making this journey a monumental challenge. Starshot, a project aimed at reaching Alpha Centauri, is considering using lasers to propel a spacecraft to its destination, offering new hope for interstellar exploration. The main challenge lies in Earth's atmosphere, which distorts both incoming light and laser beams, making it difficult to generate the necessary force to propel a spacecraft. A study proposes using inverse adaptive optics to solve this problem. Small lasers aboard satellites would measure atmospheric effects in real time, allowing much more powerful ground-based lasers to adjust their focus on the space probe. Lasers with a power of 100 gigawatts would be required to propel the spacecraft, an amount of energy comparable to the total electricity consumption of the United States. However, these lasers would only need to operate at full power for about 10 minutes. To distribute this energy over an area of 1 square km, the plan is to use about 100 million lasers. The Starshot team is committed to taking space exploration to the next level. Once operational, the spacecraft would reach an astounding speed of 20% of the speed of light. With an approximate size of 10 m in diameter, this spacecraft could reach Alpha Centauri in just 22 years. Nevertheless, the spacecraft could be significantly slowed down by the sun's gravitational pull and interstellar debris along its path. Even if it reaches Alpha Centauri, its transmissions would take another 4 years to reach Earth. Scientists are aware that one of the biggest challenges is preventing the probe from melting. To achieve this, the spacecraft's mirror would have to be nearly perfect, reflecting 99.99% of the light that hits it, in addition to doubling the momentum transfer and minimizing heat accumulation. Within days of launch, the probe would traverse the Alpha Centauri system without approaching any planets. The exciting aspect of this concept is that once the launch system is operational, multiple probes could be sent at a reasonable cost. The opportunities to briefly detect Earth-like planets would increase considerably if a fleet of probes explored nearby stellar systems. The possibilities are enormous. Upon reaching Proxima Centauri, humanity could have access to an entire stellar system to explore. How many Earth-like planets might be waiting to be discovered? Exoplanets are planets that orbit stars outside our solar system, and thousands of them have already been discovered. In 1992, scientists detected planets around a particular class of neutron star called a pulsar for the first time. 3 years later, the first planet orbiting a sun-like star was discovered. Since then, many more have been found, including several Earth-sized planets located in the habitable zones of their stars.